everyone. This session is called, Are You Smarter Than a Web Browser? And don't worry, I'm not going to go into all these philosophical debates about whether a man is smarter than machine. What I do want us to focus on today is see how much do we know about the way that the browser operates, and specifically about the very sophisticated optimizations that have been added to browsers in the last couple of years. Because whether we realize it or not, when we become web developers, we start constructing this mental model of how a browser works and behaves. And if there's a big enough gap between the browser as we assume it is and as it actually is when our users are using it and our code is running, then if that gap is big enough, that's going to lead us to make misinformed decisions, to write code that is not in the ideal way that it can be, and ultimately to ship a bad experience for our users. And I'd like to illustrate how this can have real-world effects with this example which I want to share with you. So we're going to be seeing a lot of this guy throughout the talk. As you can tell just by looking at him, this is a product manager. And he has a lot of interesting ideas about the kind of features we should build, but ultimately how we build them is our decision. So this first requirement that we're going to get from him is for a fairly technical feature, a feature that's all about performance and making our site faster to use for our users. So his idea is this. We currently have mobile users and desktop users, and we have a subset of all of our CSS rules that only apply to this type of device or that type of device. And right now we're shipping down all those rules to the client regardless of the type of machine that they're using. So why don't we take the time to create two different CSS files, one for mobile, one for desktop, in addition to the main CSS file which doesn't change based on your device, and only send the relevant file down to the client. Now let's assume that we follow this requirement and this is the code that we end up writing. So it's a very simple HTML file, but let's go over it. So we start off with a normal link tag to load our main style sheet, which is the parts of our CSS that don't change based on the device, followed by an inline script tag where we check what is the width of the device we're on. We're making an assumption that that's good enough to say that these rules are relevant or not the other set of rules. And so we decide which one of these files, Cat's mobile or Cat's desktop, is the one that is relevant. And we dynamically create a link tag to download it. Now, I want you to think when you see this code, first of all, how does it achieve the goal that we had in mind for this feature? Well, we improve performance before and after this feature. And on top of that, there should be something that should be fairly obvious, or if you understand how the browser works, about how this code will behave. In fact, I'll give you a little bit of a spoiler and say that there should be an alarm going off in your head right now about this code. And I'll explain what I'm alluding to in a minute. But this is true for all of the code samples that I'm going to be showing you today, but this is the only time where I'm actually going to say, keep an eye out for what are the gotchas and the pitfalls in these code samples. So let's see how this code behaves. So you can see here that I achieved my goal in the sense that I have the two style sheets that I wanted to load. And the second one is only relevant because this is a desktop machine. And also in the waterfall diagram, I can see that the network requests indeed behave like a waterfall. So only when one request finishes downloading is the next request able to begin. So to understand if this is something that can be improved upon, let's take a look at a more simplified use case. Let's take a standard HTML page, none of this dynamic decisions that we have to make about which file to load, just two standard link tags. And I want you to think, how will this behave? Will these two files in this case be downloaded in parallel or sequentially one after the other? So think about it based on your experience working with browsers and as web developers. And now I will tell you the answer. The answer, of course, is that this is a trick question because there is no single answer. It depends, as always. Because older browsers, this is a screenshot from Internet Explorer, I'll remind you again, this is the simplified case where it's just 2 link tags, no inline JavaScript or anything like that. They would handle this by downloading these 2 requests one after the other sequentially. Modern browsers, on the other hand, this is a screenshot from Chrome, would download these 2 files in parallel. Obviously, in terms of the performance and the user experience, this is the more appropriate, better option. Now, those of you who assume that these files would download sequentially one after the other, you probably assume that because, and you're right, you're familiar with the fact that some resources are considered render blocking. So when we apply style sheets and script files, the order we apply them is important, and we can't have that changed based on which file happened to come in faster over the network for that user. Now, older browsers were able to promise you this, that these files would be executed one after the other just by, when they encounter one file, stopping the parsing completely, download the file, parsing it, execute it, and only then move on to the next one. Modern browser vendors, on the other hand, realized that they have to respect the same rules in regard to render blocking resources, but they can still optimize this. So they created this optimization where, giving the same HTML, now these CSS files would be downloaded in parallel. They just hold off on actually applying them until the first, or the file that was requested first, has finished loading. So I want you to think about what this means for a minute, okay? This is an optimization. This is a feature that one team that's building the web browser is able to ship. And suddenly, the experience of everyone using the internet is better without each one of the websites updating their code. So it's a huge optimization and a really big performance win that we get absolutely for free. In WebKit-based browsers, the component that is responsible for this is called the HTML preload scanner. While the main document parser, the HTML document parser, has to respect these rules when it parses the HTML about render blocking resources, this other component can go ahead and look ahead inside of the HTML and try to find the resources that are going to be needed anyway and queue up their download immediately. So now that we understand this, let's go back to the code I showed you earlier that we wrote together. So by now it should be clear, because we already saw that in this case, the files download sequentially one after the other, and yet in Chrome, out of the box, we get this ability to download files in parallel, that this is the problem with this code. But it's, depending on your experience, it might not be immediately obvious when you look at this code. So let's try to understand how to fix this particular problem. Well, this is just one way to do it. But what you can do is, in fact, have a link tag, one for the mobile version, one for the desktop version. And you decorate each one with a media attribute that tells it which width of the screen it applies to. Notice how much more this syntax is kind of more declarative, and we're communicating our intent to the browser. Now let's see what the browser is able to do with this. So I'm filtered here just on the CSS files. And as you can see, I have the main CSS file and the desktop. So the desktop is loaded first because I'm on a desktop machine. And in terms of the waterfall diagram, they download exactly in parallel, just as we would prefer to have. Now, notice that the cat's mobile version is also downloaded, but it's downloaded later only after the DOM content loaded event is fired. So this is really giving us the best experience, because the file we need the most is downloaded in parallel with the main CSS. And when the network stack is idle and we have some resources to utilize, then it also downloads the mobile version. So if I change the width of this window, I will still get and have those rules be applied. One more thing to note here, we can add this priority tab to Chrome DevTools, and it can actually show us how the browser is able to understand the importance of each one of these resources. And we can see indeed that the desktop version has the highest priority along with the main CSS, while the mobile version has the lowest priority. Now, this is just one example where we had this requirement where we wanted to load one file dynamically based on the width of the screen. But in general, this is indicative of something more widespread in modern front-end development, which is that we use client-side rendering frameworks pretty much exclusively. So that means that if we're not aware of this, this ability of the HTML preload scanner, and we're writing our code inside of JavaScript, basically our HTML inside of JavaScript, then we can create a case where the only time that the browser knows that there's another resource that it needs to go and fetch is only after the JavaScript has finished being downloaded, parsed, and executed. So we got this really great optimization, absolutely for free, which is the preload scanner, and we're accidentally opting out of it because of the way that we're doing it. So the most important thing is to be aware of it. Once you're aware of it, there are plenty of ways to fix this. Here's another one. You can use preload tags. Preload tags tell the browser, I'm going to need this resource down the line. This is something that the preload scanner can find because it's simple HTML and it's standard. And it goes ahead and it downloads this resource for when you will actually need it. Now, as I hope this example shows, this signifies that there's something unique about building in the web platform as web developers. Usually, when we build on top of a platform, we're told the platform has the public API, study that API well, become an expert on writing code for that public API. Don't worry too much about the underlying implementation. If you're curious and you want to learn about it, you can do so just for fun. But in fact, it's sometimes discouraged to write code based on your assumptions about the implementation because the implementation might change and you don't want to write your code in a convoluted way. But as I hope this previous example shows, there are sometimes really good reasons to learn about the implementation. Because if we weren't aware that we get this behavior from the browser, and this is something that is an optimization that browser vendors chose to do, then we might miss out and write code which accidentally disables this optimization. So the structure I'd like to follow for the rest of this talk is to keep showing you these examples of very innocent-looking code. And then we're going to see what is it about this code that makes this code into a foot gun. A foot gun, if you're not familiar with this term, is a piece of code that, again, looks pretty innocent, but without noticing it, you're actually shooting yourself in the foot. We're going to take a look at a few of these examples. And again, I'm reminding you, have that critical thinking. See if you can spot for yourself what are the problematic issues with all of these examples. And one more thing before we move on. If you already see these examples and you already know what the best practice is, like I'll show you the before and after, and you'll say, I already do this in this better way. It's okay to pat yourself on the back, but don't pat yourself on the back and congratulate yourself too much if you didn't understand why you do it. If you only took it as a rule of thumb that you inherited from someone you used to work with or from some blog post that you wrote, then that means that you're trained to identify this problematic code only in one variation which it appears in, and you might miss out and not recognize it when it manifests itself in a different way. Only when you realize really why we have this best practice and how the browser works, you'll be able to identify it in any way that it pops up. So let's take another feature from our friendly product manager. And this is another feature that's about performance. It's about making the experience better for the user in terms of performance. He's saying we have a feed page which contains a lot of images, and the user may not scroll down all the way to the bottom of the feed, and we're currently downloading all of the images that are in the document, regardless of whether or not the user is actually seeing them. So instead, why don't we only load the images that are inside the viewport as the user scrolls, downloading more and more images? So with this requirement, let's assume that this is the code that we write. So the first thing we do is we have a placeholder URL for each of our images, and we store the actual URL of the image in a data attribute that we can access later. And then, of course, we need some extra JavaScript to get this working, so let's go through it. The first thing we would do is we would add an event listener for the wheel event. And when that is triggered, we're going to call the onViewPortMove function. Why the wheel event? Because when I'm using my Mac here and I'm scrolling down, this is the event that is triggered. We're also going to be calling on viewport move synchronously immediately because we want to download the images that are above the fold even without the user still having a chance to scroll. Inside this function, this is what we're going to do. First, we're going to find all of the images that need to be lazy loaded. We're going to filter that list and keep only the images that are currently in the viewport. We can do this by checking the bounding client rect of the image. And then once we have the images that are inside the viewport, we can get their URL from the data attribute and set that as the real source of the image, which will queue up the image download immediately. And then just to wrap up nicely and prevent ourselves from doing needless work, and the next time that we run this code, we can remove the class that we call lazy load that signals that this image needs to be lazy loaded. Let's see this code in action. So first off, you can see that as I'm scrolling down, the placeholder images become the main images, which is what I wanted. Now, I'm going to add a component to this page, and I'm going to use this component a few times throughout the talk, so let's explain thoroughly what it does and what it represents. When I click this checkbox, what's going to happen is that I'm going to set a timer to execute every 4 seconds, and then every 4 seconds, it's going to execute long-running synchronous JavaScript that is going to keep the main thread busy for 3 seconds. So 3 seconds, main thread is completely busy. There's no chance for any other JavaScript to run. 1 second, any work that has been queued up can still run, and then it repeats itself. Now, what is this here to simulate? I'm not purposefully making the code that I just showed you. I'm not making that code slower. I'm just doing this to simulate other work that is happening inside this web application. Okay? These are other models, other parts of the application that have nothing to do with this feature. These are features that were written 6 months ago or are going to be written 6 months from now. Now watch what happens when the main thread is busy doing something else. You can't see my hands, but I'm constantly trying to scroll, and only when it's not blocking in that 1 second that it gets back control of the page, I'm actually able to scroll. So this is a fairly bad user experience because users, they're fine if an image takes a few milliseconds to load, but if they can't scroll the screen, it really feels broken. It feels like the page is completely blocked and stuck, and this is something that they would expect to happen and try to like restart the tab or something like that. Now, you might think that we can't do better, that this is just the way that the browser behaves, but I want to show you how this same page works without the lazy loading mechanism of images only in the viewport that I just added. So now, when I block the main thread, scrolling stays smooth, even if JavaScript is busy doing other things. So we know that this is already in direct result of the code that we just wrote. And obviously, we want to make the experience better and not worse, so that means that there's room for improvement here. So let's see a solution. We can debounce our event handler. I think this is a fairly well-known practice. Some of you are already familiar with this. What this means is that the wheel event is actually triggered many times as I'm in the process of still scrolling, and that means that my onViewPort-move function is being called a lot of times. By debouncing it, we're only calling that function once after all that interaction with the wheel has actually finished. So let's see this in action. And now, when I block the main thread, I still can't scroll. This has nothing to do with the actual problem. I'm not saying that debouncing your event handlers is a bad idea, but you have to understand what problem it's actually solving. The problem here is that while the main thread is busy, it can't call our event handler, and it doesn't matter if it's debounced or not debounced. It doesn't even get to that point where it matters. So we still have to fix this problem. What could help us understand what the problem is this ability inside of Chrome DevTools. You can go to the rendering panel and ask it to show me elements that might suffer from scrolling performance issues, which is exactly what we have. And it's not super helpful because it's highlighting the entire application, basically, but it is verifying the fact that there's a problem here. Because we have a mouse wheel event listener basically in our entire application, then we have this problem with scrolling and smooth scrolling. So to really fix this, we have to understand what is happening here. So it kind of makes sense that because we added an event listener for the wheel event, then the browser has to couple these two things. Smooth scrolling is now coupled with the fact that we have an event listener. But why is that, in fact? Why does the browser absolutely have to wait for our event handler to run before it can decide if it's going to scroll or not? Well, it's because for many events that the browser exposes and lets us add an event listener to, the browser already has some action that it does in response to that event, whether or not we have an event handler. So when we touch the trackpad on a Mac or the mouse wheel, what we usually expect to happen is for the viewport to change and for us to scroll down. And we have the ability to cancel this native response inside our event listener. If we call prevent default from our event listener, then the viewport will not change, even though I touched the mouse wheel. So this is the real reason that the browser absolutely has to wait and run my event handler, because it doesn't know whether or not I'm going to be calling prevent default, and it must assume that I may do it, so it has to wait for that. So to fix this problem and still provide smooth scrolling even when there's JavaScript running elsewhere, the ideal solution would be to somehow tell the browser that I promise to never call prevent default, and it can go ahead and provide the smooth scrolling, and only when the main thread is available to run my event handler, it can do so in addition to the native behavior, which is to scroll. And in fact, that this is something that I can do. So if I pass a third parameter to the way I register my event handler, and I declare my event handler as a passive event handler, then this is exactly what I'm signaling to the browser. I'm saying I promise to never call prevent default. If I call prevent default, you feel free to completely ignore that. And therefore, you can go ahead and provide smooth scrolling even if you can't run my event handler at that time, and when you can also call that event handler. Let's see this in action. Now if I ask it to show me all the elements that have scrolling performance issues, you can see it doesn't highlight any element. But more importantly, now even when the main thread is blocked, my placeholder images can't turn into the real images, but still the scrolling itself stays smooth. Now for this particular use case and this particular feature, there are also other ways you can do this. You can use an intersection observer, which is a newer browser API, but still has fairly good adoption. And also, interestingly, just last week, Adi Osmani announced that completely native lazy loading of images and loading of images that are only of the ones that are inside the viewport is coming natively to the browser, and this is shipping in Chrome 75. I think now we're at Chrome 73, so this is pretty soon. But it's just an implementation of a proposal. It's not yet a standard, so the way that it works might still change. But still, it's pretty exciting that we can get all of this behavior now for free. But regardless, I hope you learned how we can have these issues that might not be so easy to spot with scrolling and with adding event listeners, and how by making them passive we can fix that. But of course, there are some legitimate cases where we're going to have to be calling prevent default in order to support some feature. Otherwise, we would just make all event listeners passive out of the box. So now let's see another feature requirement that, where that is true. We're going to have to call prevent default in order to support the feature. And still, knowing what you now know, stay alert and see how we can improve upon this code. So this is the requirement that we're going to get. We have a feed that's optimized for mobile use. And as you know, on mobile, the way that we scroll up and down is by swiping up and down on the screen. So overall, that's how this page will behave as well. As I swipe up and down on the images in my feed, I'm changing what is the viewport and I'm scrolling. But I want to give special behavior specifically for these video elements that I have on the page. These are sunset videos shot from the Wix offices. And when I swipe up and down on them, I don't want to change what is the viewport. In fact, when I swipe down, I want the sun to go down. When I swipe up, I want the sun to go up. So it's going to look like this. So it's a pretty cool interaction, and let's see how we can do it. So again, a bit of JavaScript. We're going to add an event listener just as before. This time we're using the touchMove event listener and calling the onTouchMove function. Inside this function, what we're going to do is we're going to check if the element that you touched is a video element. If not, do nothing. But if so, prevent default in order to disable the native scrolling. Then we want to figure out where you are if you touched near the top of the image or the bottom of the image. So in order to do that, we're going to take the data from the event and divide that by the total height of the video. And we'll get that as a ratio. If we apply that ratio to the duration of the video and set that as the current time, we're going to achieve this interaction and this behavior. Let's see how this code works. I'm going to emulate a mobile device. And I'm going to add my main thread simulator. Now again, you can't see what I'm doing here, but I am trying to swipe over this cat image. And I can't do it when the main thread is blocked. So even though the requirement I got was to only add this bit of special interactive behavior only for the video elements, again, I ended up hurting the entire experience and making it worse off than before. Now, we know we can't solve this by calling by declaring our event listener as passive, because in some cases we do want to prevent the default behavior. So how can we still improve this code? Well, I don't know if you noticed it when I first showed the code, but I was using a pattern that is fairly well established when working and registering event handlers on the web, especially if we have a feed where we might have infinite scroll and more items coming in down the line after we reach the bottom. And that is that I only had one event listener for the entire feed component. And then inside my event listener, sometimes I decided that this event listener is not relevant at all for this component, so I do nothing and I just return and exit the event handler function. So here the solution actually is to go the really old school way and to register the event handler every time for every video element, so I'm not affecting the majority of elements on my page, which are the cat images. And yes, this means that if I have infinite scrolling and infinite loading, I still have to realize when I'm adding more videos to the DOM and then to add an event listener every time. Let's move on to the final requirement that we're going to get from our product manager. You can just tell by that look in his eye that he has an idea for a new feature. And this time he even provided a mock-up. We're going to have an image in our page, and it should animate and move from left to right and back again. Now, we're front-end engineers. That means that JavaScript is our hammer and everything is a nail. So let's solve this with JavaScript. Now, typically, the way that we do animations in JavaScript is like this. We have a function, and that function is going to calculate where we should be in every step of our animation. So this is our step function, and let's see what happens inside. So we take the current time, we subtract that from the time the animation has started, and that shows us how far along we are in the animation, closer to the beginning, the middle, or the end. We divide that by the total duration of the animation, and we get that as a ratio of where we are in the animation. We apply that ratio to the distance we want to cover in the animation. This time we're going all the way from left to right. And that gives us the current location that the next step should be at. We apply that to the DOM, in this case by setting image.style.left to that value. Now, other than some handling of edge cases here that we won't go into, that relate to reaching all the way to the end or the very beginning of the animation, the next step is to just set this function and make sure that it's called again when we're ready to compute the next step of our animation. And we do that by calling Requestanimationframe. As the name suggests, Requestanimationframe is the ideal browser API to use in this case. What it does is it calls this function that we pass it as a callback at the time that the browser is ready to paint the next frame on the screen. So that's the API we chose to use. Let's see this in action. You can see I have my animation working. And now, when there's other work going on in JavaScript in my application, my animation becomes stuck. Now, I don't think this will surprise anyone. Obviously, if what is powering my animation is JavaScript, then if JavaScript has no capability to run because it's single-threaded and it's doing something else, then my animation won't run smoothly. So what can I do? It basically means that I can't use JavaScript to power my animation, and I have to use something else. So I'll get rid of my JavaScript, and I'll replace it with CSS. And you can see how much more declarative this code is compared to before. So I have the initial position for my element. I'm using the animation property, which signals that I want an animation. I'm saying that the animation should take 1 second for each iteration. And the property that I'm going to be animating over is the left property going from 0 to 130. So let's see this code in action now with the solution. And now when I block the main thread, you can see that my element is actually stuck again. So why is that? How come if I have no JavaScript powering this animation, if JavaScript is running elsewhere, then my animation is still stuck? So in order to answer that and come up with a solution, we have to understand something which we call the pixel pipeline. The pixel pipeline is the process that needs to run in the browser every time that it wants to calculate what is the next frame that should be shown on the screen. So let's go over the parts of the pixel pipeline to understand it better. These are the parts of the pixel pipeline. We're starting with JavaScript, of course. So we react to the user interaction on elements that we added event listeners for, or maybe a timer has fired after we set it a couple of milliseconds ago, or maybe an AJAX request is completed and we have to run the callback associated with it. Regardless, we have to now run JavaScript. Then let's assume that in that JavaScript we make some change to the DOM. So we need to rethink what are the elements in the DOM, what are our CSS selectors, and what are the rules that now need to be applied. This is the recalculate style step. Now, based on that, we probably made some changes to the layout of the page. This is the geometry of each one of my elements. I made them bigger, I made them smaller, I changed the width, the height, any property related to the geometry. That will cause a recalculation of the layout. Now, maybe I actually changed the background color of an element, or maybe just by the fact that I made some element bigger, I now have to paint certain pixels before on the screen that weren't painted in some color before. So I need to recalculate that, and that is the paint step. And finally, I have the composite step, which I'll get to in a minute. But you can already see that this is a lot of work, and as you know, we're aiming for 60 frames per second, so that means that I have to run all these expensive calculations every 16 or so milliseconds. So it's a lot of work. Now back to our problem, the animation that isn't using JavaScript but still is somehow stuck when JavaScript is running. Well, this is happening because all of these parts of the pixel pipeline rely on the main thread being available in order to run code. So it must mean that our CSS-only animation is still triggering one of these other steps, and that's why if the main thread is busy, we can't run the parts of the pixel pipeline, and that's why our animation is stuck. Now, we don't have to guess which parts are getting triggered here. There's a great resource, a website called Css Triggers. And what it does is it just lists all of the available CSS properties. And it shows you for layout and paint and composite using these color codes, which ones are actually triggered when I change this property. So if I take a look at the left property, which I was using to power this animation, and I focus on Blink, because that's the browser engine that's powering Chrome, I can see that all three steps, two of which, as we said, have to have the main thread available in order to execute, have to be recalculated when we change this property. So this is explaining what is the problem here and why our animation, our CSS-only animation, is still blocked. Now I want to just kind of cheat and give you the solution. Okay, this is the property that we should be using in order for this animation to run smoothly, but then I want to explain why this works as opposed to the left property. So in fact, if we do this, if we use the transform property and use translate x from 0 to 130 instead of left, this will run smoothly even if the main thread is busy. Let's see this in action. And now, when I block the main thread, the animation still continues to go on. So let's understand why this is happening. What is so special about when I do transform that's causing this animation to suddenly magically skip all those critical steps that we just had? So in order to understand this, I want us to talk again about the pixel pipeline. So even if we didn't know that these things are called the layout step and the paint step, it comes to us intuitively that we have the DOM, that representation of what are the elements on the page. We know what the CSS selectors are. And every time we want to show something on the screen, we have to go through this step where we calculate what are the pixels on this canvas that is the screen. And if I have an image that I'm trying to animate, if it's on the same canvas, then I'm going to have to rerun that expensive calculation as the image is actually moving in my canvas. But what if I did this? What if I had two separate canvases, one for the document and one for the image? And then I only calculate this expensive process of turning the background URL of the image or whatever. I turn that into actual pixels. I do that once for the document, once for the image. And I have these two separate canvases. And all I do is, every time that I want to have the next step of my animation, I'm just changing where one of these canvases is on top of the other. And what I'm actually showing on the screen is either the pixel on the canvas that's on top, or if it's not on top because I'm in this area, then I'm showing whatever the pixel is on this area. So all I'm doing is I'm kind of composing these two canvases together. Now this is exactly what is happening inside the composite step when I have more than one of these canvases. Now in fact, this is what is happening in the browser. But these are not called canvases in the browser's terminology, but they're called layers. And when I'm using transform, the browser is able to understand that I want to have this special behavior, so it's creating a new layer specifically for the image that is being animated over. And I can verify that this is happening and get a glimpse of what is happening in the browser by using the layers panel inside of DevTools. And it can even show me this 3D representation of the layers in my application, and I can visually see that I have a new layer here that is just for the element that I'm animating over. So you might think that the takeaway here is to just put transform on everything, and then I'll never run into this problem. Now, of course, there's a reason that this is bad practice, otherwise it would just be the out-of-the-box behavior. When I promote something and give it its own layer, it requires more memory. And also, this decision where how do I compose these two layers together, this is a decision that happens on the GPU. And low-end devices like mobile devices have fairly limited GPUs. So we need to use this with caution and only use it when it's actually relevant. Now, some of you may already know that we have this trick with transform and maybe used it before. I hope now you realize how this works. We also have other ways of promoting elements into their own layers. For example, the will change property. But again, use it with caution, and also know that you can use the layers panel to actually verify what are the layers on the page. The slides and the demos and the code for everything I showed you today is available on this website, footguns.yonatan.dev. It's written in a fairly fun, old-school way, so the code is just embedded in the demos. It's not bundled, it's not minified. In fact, all of these examples work on older browsers, so you can compare how it works with and without the browser optimization. I want to thank these people for their blog posts and talks that inspired the examples in this talk. Also to Alon, who helped me out from Wix. And finally, I want to leave you with this. First of all, I only showed you a few examples. Obviously, there are more. If you're familiar with more of these type of gotchas, it would really be cool if you came up to me and told me more about them. I'd love to compile a really long list of these foot guns. But other than that, I really hope that the takeaway is that in order to learn to identify all these foot guns, it's really critical that we understand how the browser works. Otherwise, we can only identify a small subset of these. Because if you think about it, we call ourselves web developers, but what we really are developers on top of the web for the web. The real web developers are people like this person who is actually the web developer because he invented the web. And other web developers are people who are writing standards and people that are implementing those standards inside of browsers. And I would argue, and I hope I showed you here today, that in order to be a really good web developer from the type we are, in order to develop for the web, we have to adopt the mindset of these types of web developers. Thank you.